Hello, folks. So we are now going to do Unit 3.2, which is the surface area of pyramids, cylinders, spheres, and cones. So before we did 3.1, those were simpler shapes, right? Triangles, squares, rectangles, all the fun stuff like that. Um, Whereas now what we're doing is we're looking at some more complex shapes. So here's what we're going to do. Um, so we're going to try this out. Now, just like before, I want you guys to ignore the answers and stuff below. It gives you the solutions. You're not really going to learn that way, right? Let's explain through it. I want you to use this space that we have here to actually write it in. Ignore the stuff. Literally take a piece of paper, cover it up. Don't look at the solution. So we got to walk through the process here. Now, if I'm looking at this figure here, this isn't a simple figure, right? This is like a pill shape. I need to break it up, just like how I broke up, some of these shapes here. Like with this one here, you would have broken it up like into this triangle, into a square, into a trapezoid, into a rectangle, right? You break up a shape into simple ones. Well, with this one, oh, this is just a rectangle and two circles, right? So what this is, this shape here is just, it's a half of a circle plus a rectangle plus a half of a circle. Well, how do I find a half of a circle? Well, I take a circle, I cut it in half, or I can just combine these bad boys into one circle, right? So it's a circle plus a rectangle. That's all it is. So the circle in this case, what's my area for a circle again? Well, isn't it pi r squared, right? What's my radius of this? Let's find it out. So the area of my circle here is pi. I'm just going to write pi times my radius, which is 58.4. No, it's not. Some of you caught me there. This is a diameter, right? This here is the diameter of the whole thing. I don't care about the whole thing. I only care about half of it, right? So I got to cut 58.4 in half. Divide it literally by 2. 29.2. So it's times 29.2 centimeters times 29.2 centimeters, right? Because that's squared. Right? So pi times 29.2, and you can use the square feature if you want. It doesn't matter. 29.2. It is 2,678. We're just going to keep it like that. 2,678 square centimeters. So that's the circle. Now let's do the rectangle. Well, rectangle is pretty easy, right? Area is just length times width, right? So my area equals my length, which is 112.6 centimeters, times my width, which is 58.4 centimeters. Multiply those together. 58.4. I'm going to get 6,575. I'm going to round that up to 76 and just leave it easy. So 6,576 centimeters square. Now, down here below, they're going to give you some decimals. I don't care right now. I really don't. If you guys can get to this point, you've shown your work, full marks. I really don't care about the rounding. Round to make numbers easier. That's totally fine. So now all I got to do is add these two bad boys up, right? So 6,576 plus 2,678. That's my cat if you can hear him. 9,000. Here, let's say again. 6,576 plus 2,678. 9,254 square centimeters. 9,254 centimeters squared. My final answer, I'm going to circle it. So that's how we do it, right? You break it up. Not so much the case sometimes with our other ones. Now, I'm going to get you guys to do this really, really quickly. One thing to keep in note is like break it up, right? So I'm going to give you a second here. Before we do anything else, I want you to break up question 1, 2, and 3. Actually, just break up question 1 and 2. 1 and 2. So you're not solving it, just break it up. Draw the lines through it. 3, 2, 1. Now for question, my cat. For question 1 here, well, that is just a rectangle. Looks like a square, but we're not sure. And a half of a circle, right? Whereas this one here, a triangle and a half of a circle. We'll deal with question 3 in a second. I want to solve these. So now what I want you guys to do is try and solve these. Now, the one thing before you go into it, though, is it's a half of a circle, right? How do you do half of a circle? Find the area of a full circle and divide it by 2. So 3 seconds, I want you to solve questions 1 and 2. 1, 2, 3. Okay, question 1. What was my mistake? I didn't cut the circle in half, right? It's very easy to make mistakes. Do you notice why I wrote this up here, right? It's a 2-second note. That took me 2 seconds. That's my reminder of what to do. So this is not the correct answer. Instead, I need to cut this 9.62 in half. 9.62 divided by 2 is going to give me 4.81. So now I can add up these two numbers. 11.375 plus 4.81 gives me 16.185 centimeters squared, which is my final answer. All right, question 2, do the same thing, but remember, it is a half of a circle. It's a triangle plus half of a circle. All right, go. Okay, now for question 2, right, my circle, I got 36.3. I had to cut it in half. I got 18.15. My triangle, it's a half times my base, which is 6.8, right? Both these lines, these red lines here are 6.8 times my height. Now the height here, this part, is just half of 6.8, right? Because the whole of it's 6.8. Half of this is half of that, because these here are parallel lines. This is showing that, hey, this line is the exact same as this line. So this half is the same as this half. Okay, and so here we are, right? So again, I took my circle, but I just remember to divide it in half. So now what we're going to do is we're going to do question 3. So take 3 seconds here, figure out how would I split this up? It's a little bit of a weird shape. So 3 seconds. How would you figure out the area of that shape? So 3, 2, 1. All right, so what you would do is just pretend this is a full rectangle, right? Pretend it's a full rectangle, and then why don't we take away half of the circle, right? Let's just pretend this part here is filled in, and then we'll take it away. So let's do that, right? So let's imagine the area of let's do the area of the rectangle, right? So the area is equal to 250 times 210. Hey, that's pretty easy, right? Nothing fancy involved. 250 times 310, 77,500. 77,500 millimeters squared. So check, I've done that. Now let's do the circle. Right, so circle, my area is equal to my, is pi times r times r. Right, so I'm just writing pi. You should be doing the symbol right. I'm not going to write it every time just because it's a time sink for me. Because I'm on a PC, you guys have freehand, so you can do it. So my radius in this case is, well, if the whole thing's 90, half of that is 45. You bang all those together, 45 times pi is 6,361. We'll just leave it at that. 3,660. Wait. 636, and we'll actually round that up to 2 millimeters squared. All right. I'm not done though, because it is a half of a circle divided by 2. You will get 3,181 millimeters squared. So I have measurement 1, I have measurement 2. Check, check. All I got to do now is take 77,500 and divide it by 3,181 millimeters. I'll get, let's see, 9. I'll get 10. I have 9 there. 4 here. I'll get 1. I'll get 3, I'll get 4, I'll get 7. 74,319 millimeters squared is my final answer here. Okay, so when we have 2D shapes, we can do some stuff like that. Now, we're going to be introducing you here to a cylinder. Now, the most easy example you can think of when it comes to a cylinder is what? There's usually two examples. Well, one easy example here is a can of anything. It doesn't have to be beans, but canned goods. Or maybe even like a thing of soda. Now, while this isn't perfectly like cylinder, like, this is a little thing here, we're just going with the basic concept. Now, when we have a cylinder is just two circles, right? The top circle, the bottom circle. And then this folded up piece of metal is just literally take a piece of paper. In fact, take a piece of paper, and if you fold it up, you get a cylinder, right? So it's a rectangle and two circles. That is what a cylinder is. Now, there is a new measurement here, though, and I want you to actually color this in. We have what we call a circumference. The circumference is the measure of the outside of a circle, right? So we need the circumference to be able to find, sorry, not the outside of a circle. The circumference is the outside edge of the rectangle. It's the folded up part of it. Because I know the height of it, I know the radius of the circle, but I need to know the length, right? Because a rectangle is length times width. I know one of them, but I need the other one. So we always need our circumference, and that's something you're going to have to be able to find. So you're going to actually write this in here. To find the circumference, you have two options. Literally pick one. Your circumference, C, is equal to 2. In fact, I'm going to make this a little bit bigger for you guys. Is equal to 2 times pi times r, times the radius. Or your circumference is equal to 2 times the, sorry, not 2 times, not 2. It is equal to pi times the diameter. Right? Now, if you're like, what's radius? What's diameter? That is up here somewhere. It's a pretty far ways away. Right? Page 125 of your booklet here, right? Your diameter is the full width of the circle. Your radius is half of that width. We usually work with just radius, right? Sometimes you have to convert one to the other, though. And sometimes, depending on the question, you have to do that. That question that we did up above here, I had to turn this diameter, because this is a diameter, into a radius. I had to cut it in half. Okay? So you need to do that same thing whenever you have something like this. So make sure you write this down, keep this in. You will need it. You will need it a lot. All right, so let's try and crack it. Again, just like before, ignore the solution. Ignore the frickin' solution. We don't care about the frickin' solution. All right, so first thing, right? Write your little formula. Circle plus rectangle. I know it seems stupid and silly, but I promise you it pays out. I also know I have a radius of 90. I can see that here, and a height of 300. So let's start with the circles. Those are pretty easy. I just got to solve one of them, right? My circle, my area is equal to pi times r squared. So pi times my radius, which is 90, right? So 90 times 90, right? That's what that square means. Pi times 90 is 25,447. 25,447 millimeters squared. Cool. There's the circle. Underline that. Check. Check. Now my rectangle, I know the height of it, right? The height of it is 300. I do not know the width of it. This part, which is the starts with a C, literally say it out loud. The circumference, right? Now I'm given a radius here. I'm going to use that. Circumference is equal to 2 times pi times r, the radius. So 2 times pi times my radius is 90. 2 times pi times 90. 566 is what we'll get it. We'll just say that. Equals 566 centimeters. Sorry, millimeters. Now you're noticing I am not putting squared here because I'm not measuring area. I am measuring the length of this. I'm measuring, I'll use a green pen here, the length of this. One measurement. There's only 1 millimeter that's being multiplied here. So there's not a square there, whereas there is over here. All right. So check, check, check. I have everything, right? So let's just add it up. My circle, which is 25,447, plus my circle, which is 25,447, plus my rectangle, which is, I haven't figured it out yet, right? All I do is the circumference. Again, go back to your equation. Make sure you do stuff right. I do this on purpose to trip us up because this is easy to do. So I still need to do my rectangle. So my rectangle, right? Length times width. My length is 300. My width is 566. $169,800. 169,800 millimeters squared. Underline important number. Now I can add it up, right? So now I can do it. Again, it's really easy to do those little mistakes. So you add all those up, and you should end up with 25447. Let's just times by 2 plus 169,800. 220,694 equals 220,694 millimeters squared. My final answer, I'm going to circle it. You need to get in the habit of circling stuff, or I'm not going to find your answer. Okay? So at this point, I want you guys to be working on these build your skills here. At this point, I believe you are capable of it. Let me just do a quick look through here to make sure there's nothing kind of silly. For the surface area here for question 6, remember, there is a little surface area here. You do not need to count this. You need to remove this a little bit. So you're going to do the small one. We'll say this one's small, this one's big. You're going to be taking your big one plus your small one. Sorry, I had a phone call there. So again, so you're taking your bottom and your small one, and you are going to minus the small circle twice. Subtract the small circle twice. Subtract the small circle twice, right? Because once comes from the surface area of the cylinder. Once comes from the surface area of the top half. So you just got to make sure you keep note of that. All right, I'm going to start working with pyramids now. So once you're done with these things, you can go to pyramids. So 3, 2, 1. All right, so for pyramids here. Now, pyramids, you got to think about what is a pyramid made out of? Well, a pyramid, if I give you guys the net here, again, hide the solution, is just a square and 4 rectangles, right? Sorry, a square and 4 triangles. So that's what we got to do here. So if I give you this surface area, like, hey, I want you to find the surface area. What is a pyramid? It is 4 triangles, and it is 1 square. So all I got to do is find the solutions for that, right? So for the triangles, the area is equal to a half times base. What's my base? 24 times height. What's my height? 16. Oops, sorry. Base times height. 24 times 16. Right, so 1/2 times 24 times 16 gives me 192. My area of one triangle is 192 meters squared. Now for my rectangle, right, it's length times width. I'm running out of space, so I'm kind of condensing stuff. Length times width, right? It's 24 times 24. Which is 576. So all I got to do is add these up then, right? So 4 triangles. So 192 times 4. Let's do this. Plus 576 is equal to the area. I want to do it this way just to show you a new thing on your calculator. Brackets. If I do 192 times 4 plus 576, sometimes, depending on the calculation, it's going to break it. You want to use these brackets here. I'm only times in the 192, not the 576. So if I do this, so this is saying, hey, I want you to only times this part and then add up 576. In this case, it worked. Some cases it's not going to, but anyways, it's 1,344 meters squared is the total surface area of this pyramid. So I'm going to get you guys to do the same thing for these ones. Try and do question 7 here, right? You know how to find the area of a triangle. You know how to find the area of a square. And just add them up. And I'll give you the answers in a second. So try that just for question 7. We'll talk about question 8 in a second. Okay, so for this one here, you know what? Your triangle, 21 times 28 times a half, base times height times a half. 294 is one of them. Then your rectangle, 28 times 28. All you do is add up 4 of these bad boys. You add it into 284, you get this. Now for this one here, it is a pentagon. Pentagon, right? 1, 2, 3, 4, 5 sides. So what's this one? It is we got to find the area of a pentagon. What the heck? And 5 triangles, right? So this one here is 5 triangles plus this thing. Now this thing's kind of weird. This is kind of difficult to figure out the surface area of a pentagon. We've never found out the surface area of a pentagon. What the heck? There's no formula for that. Well, there probably is, but we don't need it. So what is a pentagon? Let me actually just like try and draw this here as best I can. And I'll actually do it on here as well. Right? Middle of your pentagon. That's a triangle. That's a triangle. That's a triangle. That's a triangle. It's 5 triangles, right? So if I split this up here, this is actually just 5 triangles here. So, and those are all equal triangles. So all I got to do is find out the area of one of these bad boys. Now I know the height of this is, sorry, the base of it is 18, right? So it's the 5 side triangles plus the 5 pentagon triangles. So if I know the base of this is 18, well, then all I need is, I'll use blue here. I just need a length. I just need to know how long is this blue line here. That's all I kind of need. Now, how can I figure that out? Now, I could use some fancy mathematical thing to solve here, but I've misled you guys. Reread the question. What is it actually asking? So it wants to know, what is the exposed area of the pyramid? The pyramid, which is sitting on a table. The base, the pentagon, is not exposed. So it's actually just 5 triangles, right? So all you got to do is find the area of one of these triangles and times it by 5. We don't care about the base. Reading the question is important. I'm trying to emulate common mistakes that people will make. So if you were to do this, right, you take your triangle, times it by 5, you will end up getting 1,260 centimeters. I'll let you guys do that on your own. All right. Um, question 9. Let's read this question carefully. So it's an octagonal based, right? That is 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides. Octopus, octagon, 8 sides. So there's an octagon-based pyramid with a slant height of 18.7. This is the slant height here, right? This is the slant right here, right? And each side of the octagon measures 12.6. So this side's 12.6. This side's 12.6. The question's asking us, what is the lateral surface area of the pyramid? Well, what the heck is lateral surface area? So this is where we sometimes need to pause for a second. I don't know what lateral surface area is. What can I do to solve that? Google it. Lateral surface area is the total area of the sides of a three-dimensional object, excluding the area of its base. We don't care about the area of the octagon. We just care about the area of 8 triangles. Just like before, you guys are capable of doing triangles. Absolutely, right? So give you 3 seconds here. Try and find the answer. 3, 2, 1. The answer here for question 9 is going to be 942.5 square centimeters. It's just 8 triangles. 8 triangles multiplied together. Okay? Now, you're going to occasionally find a triangle where you need to use that Pythagorean theorem, if you remember from the very second day of class. We don't care about that right now. That is going to be something next unit. We don't care about that right now. So one thing I'm going to do is I'm going to go through every question here for the rest of the booklet, and I'm going to be like, hey, sometimes it's going to ask you this. You're not going to know the slant height. You got to use Pythagoras to figure it out. I'm not going to make you do that. I'm just going to tell you that, hey, in this case, this one is, I'm just picking a random number. The slant length is 11.5 or whatever. I'll just tell you it, okay? So I'll make sure to go through the video with that. I'll make sure to do some writing about that as well. So just be wary of that. So at this point, you guys should be able to actually, oh, sorry, we got one more. We got cones here. So you guys are good enough with triangles. You're fine. This one's a bit wonky. This one's 4 triangles, but you can do those. So do those. I'm going to go straight to cones here. Feel free to stop the video now, work on pyramids, master them, then come back. This is a lot of stuff all in one. It's fine to break it up into chunks. Okay, so cones here. Cones. So a cone is like a pyramid, but it has a circular base. And the net of a cone is a sector of a large circle and the circular base of a cone. What? Huh? So here's what a net of a cone actually looks like here. This is what a net of a cone looks like. We don't have a shape for that. Now you could turn this into like a triangle and you treat this as a half circle, but we don't know if it's a half circle. It's like, oh, that's a lot. So it has its own formula. It's very small. Box it. Put a star here. If you have a sticky note, put it in here. You have a formula sheet that was given with you. It's on the LMS too. So the area here is pi, right? Pi is pi. The radius is the radius. The height is the true height. The slant is the slant length, right? Now, you're noticing here, there's an H here. When I talk about true height, you don't use it. You don't. I care about the radius, I care about the slant length, and I care about pi. Do not worry about the true height of the cone. The true height of the cone does not matter in this case. It will later, but not right now, not for surface area. All right, so here's your formula here. Pi RS times pi times radius times slant. All right. So question 5. Find the surface area of a cone. Here's my lovely cone with a radius of 12 and a slant length of 15. Notice how I'm drawing it. Now the solution's right there. So like this is kind of hard for me to do. So I'm doing it up here. So remember, so my area here is pi times radius times slant length. Pi is pi. My radius in this case is 12. My slant length is 15. 12 times 15 times pi. 565.5. 565.5 feet squared. There's the answer for this one. And so just like before, what's my formula? Oh, this is the formula for a cone. What's my things I need to substitute in? Solve it. That's really a lot of this. Wait, what? I don't know where I paused my recording. I think it was here. I apologize. So what I did here was, remember, you have to, this area of your cone, this is just for the lateral area, which means the area that is not the circle. So you have to add the area of the circle on top of it. Just like here, I found the area of the cone, but I got to add the circle. I found the area of the cone, but I got to add the circle. So just make sure you're doing that. Now, what I was saying here is that you're able to do this, question 14, but just remember there is a diameter instead of a radius. And just like here, sometimes it's going to ask you for Pythagoras. I know one side, I know another side, I don't know the third side. Oh, that's Pythagoras. So we haven't learned that yet. We're not going to learn that till next module. So I'm just going to give you the answer in this case, okay? We don't know this crap yet. That's fine. So I will occasionally give you the answer. That's going to happen at the end of this video. That's also going to be written down in the assignments component of it. So just as an FYI, so you need to be looking at both. I'll try and include it in the lesson component, a written just cheat sheet to boom, 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 boom. These are the answers for these questions for you to be able to, sorry, these are the slant links for these questions for you to be able to use. So finish up question 15, 16, 17. Again, I will give you any information you need. All right, so for question 15, you have a slant of 21.5. Use that, right? Height, you don't need that because that's asking you to. I'm just going to do this once. That's saying the height here is a 20, and the radius is 16. So you need to use a slant here of 21.5. Sorry, not 21.5, 25.6 inches. Question 16 here, your slant is 60.5. For question 17, the slant is 35. Keep in mind there's a diameter. So finish those up. And then we're going to work on spheres. Last part of the unit. Again, break it up. 3, 2, 1. So a sphere is literally a ball. It's a ball, right? But there's not a net of a sphere. It's a sphere. It's a big 3D circle. The formula for the sphere depends only on the radius and pi. So here's the formula right here. Your surface area of a sphere is 4 times pi times radius, right? 4 pi r squared. 4 pi r squared. 4 times pi times r times r. All right. So again, make sure you have that somewhere. So again, if I have a ball here with a surface area of 9, sorry. So if we're going to skip this one here. We don't care about algebra right now. That's a later thing. So if I want you to find the surface area of a ball with a radius of 1.3 meters, right? Okay, it's a sphere. So the surface area of that is 4 times pi times r, right? Yeah, that's what it is. So then all I got to do is substitute it, right? 4 times pi times my radius is 1.3 times my radius is 1.3. 4 times pi times 1.3 times 1.3. 21 point, well, let's say just 21.2. 21.2 meters squared. So spheres aren't that tough, actually. It's literally just, here's the formula, that's it. So you guys are going to be able to find this. I trust you guys with that. Don't worry about that. Now, one thing I do want to note here is read the question carefully. The heck is a hemisphere, right? I don't know what a hemisphere is. What can I do to figure that out? Google it. It's half of a sphere, right? A hemisphere is half of a sphere. What is a hemisphere? Half of a sphere, right? Which means this is asking you to find the area of a sphere divided by 2. It's asking you to find something like this, but imagine it's 3D. So we can take this stuff and we can add it into composite or complex figures, right? So in this case, what is this? This is a cone plus the area of a cylinder. Now remember though, I got to take away minus the little circle twice because I'm losing that surface area twice. I'm losing it from the cone and I'm losing it from the cylinder. All right. So I'm not going to fully go through it here, but remember your cone is the cone part plus the circle part. So that's going to give you a number. And your cylinder is your circle plus the circle plus the rectangle. But to find the rectangle, I need to use the circumference. So you see how it's really complex here? But at this point, you guys have all the tools you need to be able to solve this. So what I want you to do is I want you to try and solve it. I'm not even going to walk through it. Try and solve it. Look at the solution below. Compare it. This is a difficult question, right? It requires you to find 1, 2, 3, 4, 5 things, and then a 6th thing, and then subtract some stuff. So it's a complex question. So try it out. 3, 2, 1. All right. So again, what they did here was they found the area of the cone. And everything else. So same thing. You can do this stuff with here. Now in this case, oh sorry, my bad. You don't need to do this because remember, area of a cone is just actually you do need to find you do need to subtract one of these circles actually. Because you can just use the formula of a cone to find the actual area. My bad. Gave you some wrong instructions there. All right, so for this one here, same thing. I'm trying. Let's try and do it. I want you to do it. I want you to do it. I'm going to walk through it though. But before I do that, complex question. I need to write my formula, right? So I'm going to take so what's the total thing of this? It is half of a circle, the left side, plus a cylinder, the middle, plus a cone. Right? So let's do the half of a circle. Sorry, half of a sphere. Half of a sphere. Right? The area of a sphere was equal to area is equal to, remember? I don't remember what it is. What is it? What is it? Look back. Look back. 4 pi r squared. 4 times pi times r. My radius in this case, well, the diameter is 0.8. Divide that by 2 is your radius. So 0.4, 0.4. 4 times pi times 0.4 times 0.4. Oh, that's not what I meant to do. 2, we're just going to say 2. Equal to 2. The surface area of a full sphere is 2. If I divide that by 2, it's 1 meter squared. So that's the half sphere. Check. Now I'm going to do the cylinder. Now I don't need the circles though for this. So I can just do the rectangle. And so it's not actually a cylinder. I'm actually finding the surface area of a rectangle in this case. So does that make sense? Is I don't care about the top or the bottom in this case. So it's actually, and we know that this part is just the rectangle. So the rectangle, right? Length times width. Oh, but I don't know the width. I know the length, which is 2.2. And the width is the circumference. So I got to find the circumference. Oh, how do I find circumference again? How do I find circumference again? Look up in your notes or just Google it. But circumference, circumference, circumference. Where's circumference? Circumference. That's a whiles away, right? So you could look up there in your book, or you could just Google it. I'm literally just going to Google it for you guys. Give you an example here. So what's the formula for circumference? Oh, C equals pi times diameter, or pi times 2 times the radius, right? What am I getting here? I'm given the diameter. So in this case, the circumference, C, is equal to pi times the diameter. Pi times 0.8. 2.5. I was going to say 2.5. Again, let's keep it simple. 2.5 meters squared. Sorry, just meters, just meters. So now I can swap that in here, 2.5, right? So now my area of my rectangle is equal to my length, which is 2 times 2, times my width, which is 2.5. It's going to be equal to 5.5. 5.5 meters squared. Same thing. I'm going to underline that or circle it or square it, do whatever, make sure you know. So check. Now it's just the lateral area of the cone. I don't care about this circle. The area of my lateral area of a cone. Lateral area of a cone, right? What's that again? Look up in your notes or just Google it. I'd recommend actually using ones in your notes in this case. Pi times radius times slant. Right? So the cone is pi. Area is equal to pi times radius times slant. Pi times my radius is 0.4, not 0.8. My slant is 1.4. Pi times 0.4 times 1.4. 1.76. We'll just go to 1.8 just because it keeps it simple. 1.8 meters squared. Remember, I'm not done. Write your formula. Find the surface area of the following figure. I need to add these up, right? So the area of a half sphere was 1, plus area of my rectangle was 5.5, plus the area of my cone was 1.8. You add those up, you should get 6.5, 7.3, 8.3. 8.3 meters squared is my final answer. I'm going to circle that. Okay. So at this point, you guys should be capable of finding the whole everything here. One thing to note here, question 22, total exposed. You got to get rid of some circles here for all three of these. For this one here, again, it's a hemisphere. You don't care about the circle part for either of them. So you're going to have to find that out, right? For this one here, you can do that. You should be able to find in all of this stuff here from now on. Any questions that require Pythagoras, I will go through here in about 5 seconds and give you that information, okay? All right, I've gone through it. You don't actually need any of that for the practice questions. So you're good to go. Power through it, and I'll see you at 3.3. Now for 3.3, I'm going to recommend you guys probably break this up here into 2 as well. But yeah. All right. Any difficulties? Please let me know. These are not easy questions here that you were given, especially in these final ones before the practice. Number 23, 22, very difficult questions, as well as 22 and 20, and sorry, question 2 and 3 here. So, all right, I'll let you guys get at it. Awesome.